Hey guys, welcome to my channel. I'm LeetCoder, and today we have an amazing problem for you guys. So, if you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. So, the question's called minimum distance between BST nodes, right? I'm saying. So, it says given the root of a boundary search tree, right? Return the minimum distance, minimum difference between the values of any two different nodes in the tree, right? And the minimum difference, guys, right? Which is interesting. So we're given this binary search tree, right? And the minimum distance between any two different nodes, guys, right? You know what I'm saying? The minimum one, right? Not the maximum, the minimum one is one, guys, right? As defined here, right? Because it could two and one, or it could be this one, right? Because the difference between those two are I'm saying a one, right? I'm saying two and one, distance of one, difference of one, two and three is a difference of one, right? So that's the minimum one out of the entire tree, right? You could compare with any value in the tree. Right? One and four, that's not good. One and six, that's bigger than one. I'm saying, yeah. So that's how we concluded that it could be this one, those two, or those two. I'm saying, and this one is a little bit different as well, right? You see, you got zero. I'm saying, again, this nice a binary search tree. It could be this one, right? Since there's only a distance of one, right? This one, there's a distance of what? Of a lot, right? I'm saying. This one, there's a difference of a lot. And this one is only a difference of one, guys, what I'm saying. So it could be either this one or that one, right? So that's why we return whichever one, which is the minimum one out of the entire boundary search tree as a one, guys, right? So this is very, very interesting, guys. So how can we go about solving this problem, guys, right? What kind of thought process that we need to solve it? Saying, um, we see that, so the way we could solve it, right, I'm saying a naive way that I'm thinking about, right, is to add all of the nodes of values in a list, right? And then sort the list and then compare every value with its adjacent neighbor, I'm saying. You compare them one by one, I'm saying, with the number that's adjacent to it, right? Uh, you compare those, right? Because you're trying to find the minimum one, right? Because the minimum one is going to be happening with values that are adjacent to each other, or neighbors to each other, right? That's how we're gonna be able to find the minimum one, right? I'm saying was the logic behind it. I'm saying because it'll be sorted in a sorted manner. I'm saying so that was kind of the thought process. So this process will obviously not be too efficient. I'm saying we could do a little bit better. So how can we go about it, right? So another way that we could go about it is to pretty much kind of introduce just doing a since this is a binary search tree, guys, right? We know everything to the left side of every node is less, everything to the right is bigger, right? So we can take I'm saying advantage of those properties to efficiently solve this problem, guys. So the way that we can solve this problem is to by doing the in-order traversal of the binary search tree, guys, where it's going to yield us the uh, of having the um, element in a sorted manner, right? So pretty much we do the in-order traversal, and by doing in-order traversal, we know that we get the numbers and a non-decreasing way, right? So which is why we're going to be using the fact that we can do in-order traversal. What I'm saying so. By doing that, right, we're going to have a previous variable, right, that's going to help us in keeping track of whatever number came prior to us, right? So we can efficiently calculate the difference between the root that I'm on right now and the previous value that I got, right? Because I know the previous value that was in the traversal, I'm saying, is lesser than I am, right? You know what I'm saying? Because we're doing the in order traversal of the tree, guys, right? So since it's less, I'll compare uh my value with its value, right? Trying to get the difference between the two. And also have a val or another variable that's going to keep track of the minimum one, right? So we do that for every single node and the boundary structure, guys. What I'm saying, we traverse the whole tree, and that's how we're gonna get that nice O of n time complexity, guys, right? So which is a very, very good one, right? I'm saying so. Yeah, so this is an efficient way of doing this. So let's go ahead and code that up real quick and see if we understand what we're trying to say, right? So I told you guys we're gonna have a previous variable, guys, right? Which we're gonna have right here, and then we're gonna have the minimum one, right? So this is gonna be the value, the variable that's going to keep track of the minimum, right? The minimum value, guys, right? So what we're going to do, we're going to have a min. It's going to equal to, so the min, right? You know what I'm saying? is going to equal to all the maximum value possible. You know what I'm saying? Integer that max value. Okay. And then the previous variable we're gonna have as -1, right? To signify that we haven't processed anything yet, right? You know what I'm saying? And we're gonna have we use a helper function to kind of do the in order traversal, guys, right? Okay, and just bring that down real quick. All right, so now we're good. So now we're gonna have a helper public. We're not returning anything, and then the helper. All right, so we're gonna have a tree node root. Return, guys, return the root. You know what I'm saying? Okay, we're gonna have root right there. That's good. No, we're not gonna now we return root. Oh, sorry about that. I meant we're gonna return the minimum one, right? You know what I'm saying. So if the root equals null, right? For null will return. You know what I'm saying. I told you guys we're gonna be doing the inward traversal, right? So what we're gonna do, we're going to visit our left side, right? With that left reading, go to the left, and then now we're gonna check through the traversal of the left side if our value, the previous value, right? It does not equal to -1, right? So that means that I have some kind of number to kind of calculate the distance with, right? I'm saying. So it's going to be the current min that I have right now, or right, it's going to be the root that val minus the previous, right? I'm saying. And after I do that, I go to my left, to my right side, right? I'm saying. And you know that before you go to your left side, you need to make sure that you update the previous variable to equal to the value of the current node that you're on right now, right? I'm saying. And just like that, guys, I think we are in good shape. Let's press run code, see if we pass. I meant to do passing the right, guys, right? That's what I meant to do, passing the right side, right? So it looks good. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to kind of watch this video, guys. If you guys found value, make sure you give me a like. If you guys are new here, make sure to subscribe, guys, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.